Hello there. In this video we're going to prove the ratios in the special 45-45-90 and 30-60-90 triangles. Without loss of generality, I'm going to call my hypotenuse here 1. And I know that because these angles are both 45, that this whole triangle here has to be an isosceles triangle, because the base angles in an isosceles triangle are congruent, and the converse is also true there. So this length here, I'm going to call it x, and then set up a Pythagorean theorem based on that variable x. Gather my x's, divide, take square root. This, however, is not quite the form we want it in. We want to get it in simplest radical form, and to do that we're going to need to rationalize the denominator. And there we go. That's what x is, root 2 over 2. Both of those lengths are root 2 over 2. The 30-60-90 triangle proof's a little bit different. Okay, without loss of generality, we're going to call this hypotenuse here 1. And I don't know what either of these two legs are, and they're not the same, so the mechanism has to be different than it was over on this side, where I could use the fact that it's an isosceles triangle. However, if I reflect over this line, I get this much larger triangle, and this whole thing here, 60, 60, 60, is equilateral. I know that that portion is 1, I know that that whole side is 1, so the height of this thing is 1/2. And then we just need to know what this horizontal length here is x, so I'm going to set up the Pythagorean theorem. Expand it out, subtract, square root, and take the square root of the top and the square root of the bottom. And there we got our root 3 all over 2. Okay, I'm going to give us a little bit of space so that we can summarize. Right, so on the left here, in a 45-45-90 triangle where the hypotenuse is 1, both of those legs are root 2 over 2, and in the 30-60-90 triangle with the hypotenuse of 1, the short length is 1/2, and that's what the 30 opens up to, and the long length is root 3 over 2, and that's what the 60 opens up to. I strongly suggest that you memorize these ratios because they are a building block, they're very famous, and they're going to be tremendously useful when we start rotating matrices. Character and Scholarship for Life.